Victor the Great. Welcome back to my channel. Today is the episode 2 of differential equation we started before now. If you're new here, please subscribe to my channel, hit on the notification bell so that you will be the first to receive any video I am going to drop. Don't forget to like, share, and drop your question in the comment section. Let's kick start. So we have formation of differential equation. A differential equation can be formed by differentiating the ordinary equation as many times as the number of arbitrary constants involved and eliminating the arbitrary constant. So the ordinary equation we're talking about in this context is the solution to a differential equation. A differential equation that has been solved, then giving you that particular solution, and they now want you to, from the solution, form the equation that has that particular solution. So that's the idea. Just as we have a quadratic equation, after solving a quadratic equation, we have two solutions. We have two roots of the equation. They will give you the roots and ask you to form the quadratic equation that has the roots. Just the same case here. All right. Then, what I want us to know again about formation of differential equation is a solution given to you. If a solution have one arbitrary constant, it means that differentiation will be carried out once. If the solution has two arbitrary constants, you're going to differentiate twice, and so on. If the answer solution given to you has three arbitrary constants, you're going to differentiate 3 times. So we're going to look into each and every one of them. At least we're going to stop at the one having 3 arbitrary constants. Okay. The first one I want us to talk about now is formation of differential equation involving one arbitrary constant. Example: form the differential equation from the given solution. We have A, B, and C. The arbitrary constant present in all of them is just A, one arbitrary constant. So we'll get to B, we'll see how that one will be taken care of. So, but in this case, we have just one arbitrary constant. So the first one is y equal to x plus a over x. Of course, with one arbitrary constant, I already know that the equation I'm going to form must be a first order equation. 2 arbitrary constants will give second order equation. 3 arbitrary constants will give third order equation. Alright, so the first thing to do, of course, it is easy to make A the subject in this equation. That's the first thing you think of. Whenever you're giving equation involving one arbitrary constant, check if it will be easy to make that arbitrary constant the subject of the formula. If it is easy, make it the subject and then you substitute after. Alright, so is it easy to make A the subject? So how do we do it? We multiply through by the LCM, which is x. X times y is xy. X times x is x squared, and x multiplied A over x is A. Then making A the subject, we have A is equal to, of course, xy, this crosses here, minus x squared. So that's the value of A. So this is equation 1. This is equation 1. So the next thing we'll do now is differentiate y. That's differentiate the original equation following from what we have in the formation of differential equation. We say differential equation can be formed by differentiating the ordinary equation as many times as the number of arbitrary constants. So the ordinary equation is the equation given to you. So we're going to differentiate this equation once. So the equation is y equal to x plus, we can rewrite this as a x raised to the power minus 1. Of course, before you get to advanced calculus, you must have done your introductory calculus. So differentiation is not what will come here and start releasing enough, consuming a lot of energy to explain. So we're going to have y prime is equal to, differentiating x is 1, then differentiating this factor is minus a, then x raised to the power minus 2, which we can take to be 1 minus a over x squared. So we have this as a derivative, we can call this equation 2. Then since already we've made a the subject from equation 1, this equation 1, a is the subject, we can substitute it in equation 2, which is the differentiation that we got in order to eliminate the arbitrary constant. That's what we have from the definition. So we're going to rewrite the given equation. The given equation is the same thing as this because of the denominator there. So we now differentiate once. We differentiate once. Differentiating x is 1. Differentiating this is minus a x raised to the power minus 2, because removing 1 from the power will give you minus 2. So we're going to rewrite this answer 1 minus a over x squared. Let's call this equation 2. So this is the first derivative of the given equation, and we're going to substitute equation 1 into equation 2. So a already is x, y minus x squared. So we're going to substitute it here so that we have y prime is equal to 1 minus a is xy minus x squared. That's the value of a. We substitute all over x squared. So that we have y prime is equal to 1 minus, we factor x out since x is common. We have x into y minus x all over x squared. Definitely 1x here will take away 1x, so that what we have left is y prime is equal to 1 minus y minus x all over x. So we're going to find the LCM. Let's multiply x times 1. We have y prime is equal to x times 1 is x, then minus into y minus x all over x. That's done the LCM. The denominator here is like 1, x divided by 1 is x, x times 1 is x divided by x is 1, 1 multiply this will give you the same thing, just like having minus 1 to open the bracket. So we have x times y prime is xy prime equal, that's cross multiply, x times y prime, then we have x minus times y is minus y, minus times minus, x is plus x. So x plus x is 2x, so that we have xy prime is equal to 2x minus y. So this is the differential equation, or I can have x dy over dx is equal to 2x minus y, depending on how you want to put it. So this is the required differential equation. Okay, the next one. That's number B. Y is equal to 8x plus 8 squared. So we still have one arbitrary constant, but you find that it's difficult for us to make a the subject. So what we'll do now is differentiate direct. Since we still have one arbitrary constant, we differentiate once. So we have y prime is equal to a, differentiating ax is a, differentiating a squared is 0. So we have y prime to be a. So once we have differentiated once, and the next thing is to eliminate the arbitrary constant from the given equation. How do we eliminate a? Since a is already y prime, we can substitute anywhere we see a, we put y prime, and we have our equation. This is actually very cheap. So let's call this equation 1. We can now say, okay, let's make it more. Let's call this given equation 1, and let's call this one equation 2. So we can now say substitute a equal to y prime in equation 1. A is equal to y prime. Let's put it in equation 1. We're going to have y equal to a is y prime. We have y prime x plus a is y prime all squared. So that we have, that should be the answer. Or we can recall that y prime is the same thing as dy over dx, just as we did in the previous example. Therefore, we can have y is equal to dy over dx. That's x multiply dy over dx is x, dy over dx, that's the best way to write it, plus dy over dx all squared. And that is the solution. One can decide to rearrange it. If you wish to rearrange it, you can say that this is equal to dy over dx all squared plus x dy over dx, then plus y crossing the minus y equal to 0, depending on how you want to arrange it, but that's the solution. Then the last example. We have y is equal to 8x exponential x. So this is a kind of looking like it's a product rule we're going to use. There's two functions, ax is multiplying exponential x. So it is easy to make a the subject, like I said before. If making the arbitrary constant the subject is easy, just go ahead and do it. But if it's not easy, we take the alternative way. So let's call this equation 1. From equation 1, make a the subject. A is equal to y over x exponential x. That's equation 2. Alright, so we can now go ahead and differentiate equation 1 so that y prime will give us, that's a product rule. We can, the rule of differentiating product rule is keep the first constant, that's the first function. I take the first function as ax, I keep it constant, and differentiate exponential x, which will give me the same thing, exponential x plus. Now I keep exponential x constant, and I differentiate ax, which will give me a. So in bringing it together, we have y prime is equal to ax exponential x plus a exponential x. This is equation 3. So now, how do we eliminate the arbitrary constant? You find out that equation 3 and equation 1 has something in common. You can see ax exponential x here. You can also see ax exponential x here. So we can say equation 3 minus equation 1 to see how it's going to look like. Equation 3 minus equation 1 will give us y prime minus y equal to ax exponential x minus ax exponential x will give us 0, then remaining a exponential x. So when you subtract y prime minus y, it will be equal to a exponential x. We can call this equation 4. Okay, we can now substitute the value of a in equation 4. That's equation 2. Substitute equation 2 in equation 4. We substitute equation 2 in equation 4 because a is y over x exponential x. So we'll substitute in this equation 4. We now have y prime minus y is equal to a. And what is a? Y over x exponential x. That's the value of a. Then times exponential x. So in this case, exponential x will cancel out exponential x so that we have y prime minus y is equal to y over x, which will give us x to multiply everything out with x. We have, okay, x y prime minus xy equal to, of course, multiply this one by x. X will cancel x. We have y. Then we still want to simplify it further. Let's take the space here and complete it. So to simplify this further, we're going to have xy prime minus xy, y crossing to this side is minus y equal to 0, so that we can factor y out. We have xy prime minus y is common. We have y into x plus x plus 1 equal to 0, and that is the differential equation. Thank you and have a wonderful day. The next video we're going to talk about now is the solution to differential equation.